Hi everyone. It was actually quite interesting to watch Yos's presentation just now. There was like I've never seen that slides before, but there's structurally there are quite a lot of similarities, but it's fine. I think it's actually better because now you can see the juxtaposition between SwiftUI and Jetpack Compose. So yeah, my talk is about adopting SwiftUI. Um, Happy to be here at my first ever Wolt Tech Talk, and today we're going to chat about Apple's new UI framework. Um, Again, just a disclaimer ahead of time that this is going to be more of a technical talk. So there will be code samples. So if you've never seen or written a line of Swift before, don't worry. I'll walk you through the code as I go along. So a little bit about myself. As Pedro mentioned earlier, my name is Nick Zakirin. I'm one of the iOS engineers here at Wolt. I have been doing iOS for 12 years now. I started my first app in iOS 4. Yeah, in that time, I have seen quite a bit of transitions in the iOS development from manual memory management to automatic reference counting to migrating Objective-C code base to Swift. That was a particularly turbulent time. I still have battle scars from that time. Yeah, and now from writing imperative UI to declarative UI. Right. Here's what we're going to cover today. So the talk is split in 3 sections. And first thing that we're going to talk about is the SwiftUI's layout system. This is basically how views is constructed in SwiftUI. And I think like from talking to different developers and also from listening to podcasts, like one of the common trajectory that I hear when people are learning SwiftUI is that it's very easy to get started with SwiftUI. And like the barrier for entry is very low. But no, as soon as you start to build a little bit more complicated views, like things tend to get a little bit hairy and developers just tend to throw different kinds of modifiers at it until they get the result that they want without necessarily understanding why. So my hope is that this will shed some lights into it. And the way I'm going to do it is that we're going to implement one of the views in the Wolt app using SwiftUI. And then we're going to take a peek at under the hood. This is more about understanding the lifetime of views in SwiftUI and what happens to the view when the state changes. And finally, I'll wrap up the talk sharing my experience using SwiftUI exclusively for the past year at Wolt. And also share some of the learnings that I've picked up along the way and some tips and tricks as well. All right, just wanted to give a quick showcase to one of the features that we just released last month. This is live activities, which is basically an order tracking for the Wolt app. And it's taking advantage of the new dynamic island on the new iPhone 14s and also the lock screen widget. And this is the first feature that we built and published using SwiftUI. Right. Just up front, I also wanted to bring up some key terminologies here that you might hear me repeat several times during the talk. First one is UIKit, is the Apple's imperative UI framework for iOS as well as iPad OS. And then AppKit is the Mac OS counterpart for it. And then you also hear Zip and Storyboard. And this is like the Xcode GUI builder, this kind of WYSIWYG. Apple TV, I don't know if you used to write Apple TV, but nowadays we can just use SwiftUI as well. Yeah. Yeah. What's the story? I think for Apple TV was actually, for Apple TV it was TV ML kit or something before, and I think they might have transitioned to SwiftUI. Yeah, that's right. Right. So let's jump into the layout system. So at its core, SwiftUI layout system boils down to these 3 simple steps. The first one is that the parent view proposes a size to the child view. And then second step is that the child sees this proposal and chooses its own size and relays it back to the parent. And finally, the parent has to accept the size given by the child and then position it in its coordinate space. So let's take a look at an example how this works. So what we're going to do is that we're going to rebuild this view that exists now in the Wolt app. It's been built using UIKit. And it's basically just a grid of items. Yeah, so we'll start with one of the item cells in there. It's a simple enough view. It has a image of the product, price display and price name, and a quantity control. So when you first start with developing a view in SwiftUI, this is the basic structure of a view. I have here an item view that conforms to the view protocol. Like protocol is like an interface. I think that's what you use in Android. Yeah, and yeah, the views, SwiftUI views are this lightweight description of the views themselves. They don't really map to the underlying view instances. We'll get more into that in detail. And then next, I have added here a dependency item that is annotated with the add state. And the add state is just one of the ways that you can annotate dependencies in SwiftUI. There are others as well, and I've initialized it to a mock item. Next, we have a body in the view. It has an opaque return type. We'll get more to that also in detail a bit later. And yeah, so what happens now is that I've added a text component that displays the name of the item. And this is how the view tree currently looks like. There's a root view, there's a parent to the text child view. And if you go back to the way the layout system works, like the first step, the parent then suggests, proposes a size, which is in this case, the entire screen size of the phone to the child. And the text says that, okay, I only need my exact size. In this case, I happen to know it's 200 points by 20 points. Then relays it back to the parent and says like, okay, this is my size. And then the parent has to accept that and position it in coordinate space. And in this case, then it just centers it. I think it's quite similar in Compose as well. Next, I've just added a padding view modifier that adds 12 points around this text component. And something in, I think, similar that I saw in Compose is that view modifiers return a new view in SwiftUI. So in this case, now the view tree looks like this. And the parent of the text component now is the padding view. And then, so if you go back to the layout process now, the padding view receives the entire screen size from the root view and says that I need to reserve 12 points around the space of the text, and then offers the remainder for it to the text component. And then text component that says that I still need just 200 by 20 points. And then padding then takes that, adds its own 12 points around the edges and gives it back to the root view and then position it in the center. So far, it's pretty straightforward. And every layout interaction in SwiftUI follows the same process. Now I wanted to display also the price label. And I think here where it gets a little bit more interesting, I've grouped them inside of a VStack. And a VStack is just a vertical stack that aligns all the children in a vertical alignment. And what's interesting here is that in the layout process, the parent of the text components now is the VStack. And when VStack receives the size proposed by the padding view, which is its parent, then what SwiftUI does is that it sorts all of the children of the VStack in order of least flexible. And flexibility here is defined by the range of size that the component can accept. So in this case, the text component is quite layout neutral in a way that it's happy to accept any size proposed by its parent. It can go from 0 all the way to the maximum that it needs to display. And text component will just like wraps to a second line if it's constrained horizontally, or truncates the text if it's not enough vertically. Okay. And now I've just added some configurations to make it align to the leading space with a spacing of 4, just to get it closer to the design. And just as a reminder that this is the design that we're trying to get to. Yeah, we're about halfway there, you know. Just need to draw the rest of the owl. Right. So next, yeah, so we get from the design specs that every item cell needs to be a fixed width of 176 by 176 height. So in this case, now the view tree looks like this, where the root view is offering the entire screen size to the frame that has that fixed size, frame says, no, I'm going to only offer 176 by 176 to my children. And then in the end, basically, what's interesting is now that the text label is constrained by this width, so it wraps to the second line because it still has an additional vertical space. Okay, just a point about view modifiers also is that view modifiers are return a new view in SwiftUI. So unlike in UIKit, for example, when you're changing, mutating the frame, you're actually mutating the frame of the underlying view instance, whereas in SwiftUI, you can't futz around with the frame and the bounds of the SwiftUI views. You can only give it a new view using modifiers. And because they return new views, they are also stackable. You can just add them. And when they're stackable, the order also matters. So as an example here, I've added a red border view modifier on the inner V stack. And now you can see that the Xcode preview canvas now draws the red border around the inside and the inner V stack. And then there's also a black border out on the padding. And you can see that it has that extra margin. Next, we want to display an image. So I've added now an image component. And the thing about image component is that it wants to display its image in its entirety. I think that when learning SwiftUI, the second step in the layout process, where child uses its own size, is what gets the most developers to get a bit confused. Because here, like I can try to do the same trick as earlier to put a set frame. I can say that, okay, give a maximum width of the maximum of the parent, but still, even after applying that modifier, the image still is drawn out of bounds, because here again, sort of the dialogue between the parent and the child is that the VStack is offering, here's a size of 176 by 176, but image as a child says like, no, I want to display my image in its entirety, and gives back the size of the image to the parent. And parent has no choice but to accept and position it in a layout coordinate space. And that's why it's drawn out of bounds. So the solution to this is that there's a modifier called resizable on image. Basically, just gives another copy of the image that fits into the frame of the parent. Next, I've just added some styling for cosmetic reasons to get it closer to the design. Added also a background modifier there to, it's not quite visible, but there's a sort of drop shadow and corner radius. And now we have something that looks quite similar to the design specification. I think that the things that I want to draw your attention to here is that it's quite interesting that the code in SwiftUI is very expressive. And I think you've seen it. If you've done declarative UI, it's very expressive. And all of that fits in a single slide, similar to your slide on Jetpack Compose earlier. That's very succinct code. All right, key takeaways from here is that SwiftUI views are just very lightweight view descriptions. Don't be afraid to like stack them in very deep structure, because SwiftUI is smart enough to compact that and translate that into the underlying view instances underneath. And most view modifiers, not all of them, return a new view. And because they're return new view, they are stackable, and you can also make sure that the order matters that you saw with the borders, the red and black borders. And SwiftUI components also have platform-specific defaults, meaning that, for example, if you're building that for iOS, then, for example, the VStack has defaults for the spacing and the margins that make sense for the iOS. And if you're building it for macOS or tvOS, then they have different values, default values for the spacing. And all those values match the Apple's human interface guideline. And then you saw also that SwiftUI UI components have different layout neutralities. Like text is happy to accept any size proposed by its parent, and it will just adapt to it, by truncating or wrapping to a new line. And then some other components like image, they have a fixed intrinsic size that wants to be that size, and you have to use a special modifier in order to affect change. All right, now that we've taken a look at the layout construction in SwiftUI, let's also, like, one of the things that when I was trying to learn SwiftUI that I wanted to understand is like what happens with the view lifetime. Also, what happens to the view? How does the view get re-rendered whenever the state changes? And yeah, one of my preconception when I was learning is that I thought SwiftUI was doing some kind of dynamic tree diffing to compare and identify when views have changed in the view tree. And but then I learned that state-of-the-art tree diffing algorithm has a cubic times complexity. So if you have like 10 elements in a view tree, it will take 1,000 operations. If you have 100 elements in a view tree, it will take 1,000,000 operations. And I learned that also React uses this work around this by employing this heuristic diffing algorithm that cuts down the time to linear time. And the way that they have achieved this, I believe, is also that they allow developers to give clues as to which views are stable across view updates. And also that if the two views are of different types, then the view trees will also be different. And then I learned shortly after that SwiftUI doesn't do tree diffing. And let's see what it does instead. The first thing is that it's really important for you to understand that every SwiftUI view has an identity. And identity in SwiftUI takes two different forms. One is structural identity, and the other is explicit. Here I have an example of an identity view. It has one state, a Boolean is modifying, and the body it has a VStack that has an if condition that when the state is true, when the flag is true, then it returns a quantity control in the expanded state. When it's false, it returns it in collapsed state. And here's a GIF of how it looks like. Don't correct me, my pronunciation. Yeah, so I've slowed it down a little bit to show like when I toggle the is modifying flag and what SwiftUI does, it does this kind of opacity transition between the two. And we'll see why that is the case. And in my opinion, that doesn't look right. So earlier I mentioned about the opaque return type of the SwiftUI body property. And in fact, if you introspect what is behind, what's the actual type of that, based on the body of the content of body, it is actually a type. It's a VStack that is generic over conditional content that returns a quantity, the top quantity control when it's true, or returns the bottom quantity control when it's false. So this is like static information that is known at compile time. This is what SwiftUI knows. So moreover, if quantity control has its own state that is keeping track of, like for example, it has this quantity, and you can see that from the GIFs that I'm toggling on, modifying it, modifying the quantity, switching it off, and switching it on again, and you see that the state is lost. And the reason for that is basically with Swift, when SwiftUI is trying to evaluate like what happened when you flip the switch of the toggle, then when it's true, then it's returning the expanded state, and when it's false, it's returning a different view. So SwiftUI sees these two views as distinct views, and the other one will just get destroyed along with the state that it holds. So if we go back to the example from the first section of the item view, I've just removed the body here to introspect what is the actual type that is produced. It's actually quite complex. Like it's a modified content, generic over modified content, generic. Yeah, so every modifier that you attach to a view is encoded as a type, as a Swift type. And yeah, and all it needs to do to figure out if the views have changed, just compare types and only update when the values have changed. Right, so the solution for that animation glitch there is that you use the ternary operator. And then, so why this is the solution is because now the type of the view here is just a simple VStack that is generic over the same quantity control. No matter if the flag is flipped between true or false, that is always going to return the same quantity control. And now SwiftUI knows how to animate between two states. I can also modify the quantity, and the quantity is persisted between two because it's always, to SwiftUI, it sees that it's always the same view. All right, so structural identity is great for displaying static content, but what if you want to display dynamic data? And this is why explicit identity comes in. And also explicit identity is used, for example, if you wanted to like scroll to a specific view, what you can do is assign an explicit identity to that view, and then you can like scroll to it. Let's take a look how it looks like. So here I'm trying to display an array of items in a grid, and I'm just enumerating over the items, and I'm giving it a unique and stable identity. And yeah, so now what happens is that I get a grid of 2 columns of the products. Now, of course, the items is just omitted there with the mocks. And I have here also a bit of animation here. What happens is that because each item that view that gets added has a stable and unique identity, SwiftUI is able to extrapolate between one state to another and adds the animation. So here, as an example, I'm just giving some quantity to the first 4 items, and I'm switching the sorting order from price to name. And SwiftUI, in the slide, it looks like kind of choppy, but here it looks good. And yeah, so SwiftUI knows how to animate from one state to another because the identities of these views remain stable. Right, so key takeaways from here is that, like, when I was learning SwiftUI, I think it was really important to understand how identity works in SwiftUI to write performant code, as well as achieve really good animations. And the way SwiftUI does that is by its structure or by an explicit identity. And also that you saw when you have a state that is attached to view, like if that view is destroyed, all the dependencies of it also get destroyed. So yeah, understanding identity is one of the key things that you could do if you're learning SwiftUI. Right, on to the last section about my experience using SwiftUI now, exclusively for the past year at Wolt. Yeah, we saw earlier that how SwiftUI is very expressive. I think whenever I get a design specification from a designer, I'm able to translate that design into code fairly easily without much boilerplate. You know, like for example, in UIKit, you would have to write auto layout constraints, and there's a lot of stuff just to get something on screen. But here, you know, you saw with just one slide, everything fits there, and you know, even like a non-developer could see that and see that like how that structure translates into UI. And yeah, the second thing there, like usually when I join a new team or a new project in iOS, like one of the first things that I do is I look at their contribution guidelines, like, okay, how do I do UI code in this team? And usually there's like, should I do all code UI, or should I use some sort of GUI builder like Storyboard or Zip? And teams are usually quite opinionated on this. Maybe Doug can correct me there. Yeah, so now with SwiftUI, you know, the code is your UI, and then UI, you can modify the UI in the Xcode canvas also, and they will get translated into code. Xcode does that. No more 2 camps between UI code or Storyboard GUI builder. No, but in Xcode, you can also modify the GUI itself and then get translated. So unlike with UIKit, when you build your UI in the GUI builder, that gets translated into some Apple's proprietary XML. And you can't never really debug that. It's really, when you have merge conflicts in the XML, it's always a pain to resolve that merge conflict. And SwiftUI code is also portable to macOS, tvOS, watchOS. I think prior to this, like there's really no unified solution from Apple. And I think SwiftUI is now Apple's answer to how do you write something for all their cross platforms, and all the while still respecting the platform heuristics. Another point was that, yeah, recalibrate my intuition. Yeah, so I found that I wasn't really able to use my intuition whenever we have like grooming sessions, for example. Okay, here's design, this is a feature, how long do you think it will take? After doing 12 years of UIKit, I can't really necessarily translate that experience to SwiftUI because certain things in SwiftUI is just so much faster. But then sometimes in SwiftUI, you can get there 90% of the way. And then the last 10% is like, how do I do this in SwiftUI? And then it's just like, it takes more. So yeah, the intuition for how long something takes, I think also partly is like my inexperience with SwiftUI also contributes to that. And maybe as time progresses and SwiftUI matures even more, then it will just, yeah, it brings me to the last point that SwiftUI is just a joy to use. It's just so much fun to use. I think I'm like 12 years with UIKit. I'm finding myself again, like I'm enjoying doing mobile development. And I think like one of the problems with imperative programming is that you always have to remember to keep your views in sync with the models. Like every time the models change, you have to update your views. And yeah, I think like see different teams, they have different solutions. I think at Wolt also, we've employed reactive programming to handle that problems and stuff like that. Every team has their own solution. I'm okay with RX Swift or reactive Swift, either way. But like in SwiftUI, views are just functions of state. So it's just really enjoyable to use. And a big part of it is also Xcode previews. And I think I saw that in Jetpack Compose, it also exists there. And yeah, you writing the code there, and Xcode previews immediately renders what you've written. So it contributes to really fast developments, and you don't have to anymore compile between iterations. Everything is just completely immediately visible, and that lends itself to great for prototyping. So in my current project right now, in the beginning, we had to build like a proof of concept, and I was able to use SwiftUI to quickly find out how feasible certain thing is, and I was able to give feedback very quickly with SwiftUI. But it's not all good news. Xcode previews is very, very crashy. And that brings me to my first tip. If this works, there we go. So how I've worked around the crashiness of Xcode previews. First thing is just by keeping my dependencies simple. Here I have an example of my awesome view that shows the previews. And this view happens to have a dependency on like API client analytics, can be Firebase, Crashlytics, whatever, and a logger, it can be Sentry. So what I do here is that for the previews, instead of using live dependencies, I'm just using this mock stub out, no operations endpoints and things like that. So it's very quick for Xcode to, doesn't have to compile Firebase giant library every time. And another tip that I have employed in my own project is to modularize my app, split it into smaller submodules. So for example, here I have feature A, feature B, and feature C. And when I'm developing, for example, feature A, it only has a dependency to the interface of like this logger client interface. And so I can focus my development only in that small module at a time. And only the main app then ties everything together. That, if you have the actual like Sentry backing the logger client, then that gets only compiled by the main app, not by individual modules. So that helps Xcode to do incremental builds very, very quickly. And it's less prone to crashiness. I have here a quick time lapse of what it's like. Speed it up, don't have to watch the entire thing. But yeah, so this is the example from the very first part, the item view. I'm writing I'm building the UI on the left-hand side, and on the right side, you see the Xcode preview canvas, and you see that the bounding blue box gets added. And all these things, as I'm writing them, I don't need to hit save or anything in between. Xcode, just as long as you see that it's syntactically correct, you can compile it, it renders it right there on the right-hand side. And this is how I've been building apps for the past year. It's so much fun, so easy. And you see immediately, no more compiling in between. It's almost as good as hot reloading. Because this only works in Xcode, you can't see it on a device. Yeah, I can skip ahead a little bit to the end. Yeah, I can come back to that. Yeah, in a second. It's almost done now. And also it looks great. Oh, did it miss it? There was also dark mode there, but missed it. Yeah, second to last penultimate slide. Adoption strategies. Yeah, UI kit and SwiftUI mix very well together. You can start with UI kit if you have an iOS app already that exists and you want to start adopting SwiftUI. You have a standalone view. You can build it using SwiftUI and present it from UI kit, and vice versa. Like in my project, it's a greenfield project, so I was able to start immediately with SwiftUI, and I just wanted to see how far I can push it. And whenever I hit like a feature is not yet available in SwiftUI, I can always drop down to UI kit. And the interoperability story between the two is awesome. Right, so yeah, this is a famous slide from recent Apple developer conference. The best way to build an app now is with Swift and SwiftUI, and Apple is heavily advocating and pushing for Swift and SwiftUI. and picked up this graph from a recent blog post, sort of analyzing the number of binaries in iOS that's using Swift and SwiftUI. SwiftUI was introduced in iOS 13. And it's interesting to see between iOS 15 and 16 that the number of SwiftUI apps in iOS now has doubled. So it's great to see. It's a good sign to see that Apple themselves is dogfooding their own tooling, and the community around it. There's a lot of like tutorials now, documentation. Almost every new thing that you see is written with SwiftUI. Yes. If you wanted to, I mean, you have to really enjoy pain to use SwiftUI in iOS 13, but it is possible. Yes. Well, okay. So every new version of SwiftUI, there are always new features that are available and only in that new version. I think that has been like my pain point with adopting SwiftUI, in that like, okay, I want to take into use a brand new component that's only available in iOS 15 or newer, and then I have to basically write a UI kit version of it for the older versions. So that takes a little bit more time. So my current project now, I can't talk about it publicly yet because it's not yet released, but it is targeting 14 and above.
Guys, just a second. Can we just keep the questions for later?
Yeah, there's question and an answer. Okay, no questions. There you go.
Thanks.
Pedro, come on.
Questions.
Questions.